In this video, we're going to look at treating short incisors and a compromised anterior open bite using a 3D printed XCAD trial design that is converted to final after patient approval. This lady had had orthodontics several times in the past. Her occlusion had remained stable now over several years, and she really just didn't desire to go back into orthodontics. You can see the short incisors and how it detracts from her smile. She really just wanted to improve her smile. She decided to restore 7 through 10 to improve the smile, and we would do a little zoom to improve the color. She would need an occlusal night guard after treatment in order to prevent wear to her posterior teeth. We took her scans into XCAD for a diagnostic wax up, and we're just going to lengthen the incisor teeth. Right now I've got the bite scans a little bit overclosed. It has to do with just a little bit of an analysis of the occlusion, trying to determine if I could do anything by equilibrating here, and you just can't get her to an appropriate anterior guidance through equilibration alone. It would just be too much reduction of the posterior teeth. This change to the incisor should not interfere with the occlusion, the functional, the envelope of function, nor the anterior guidance. She really has no anterior guidance. All of that will have to be established with the bite splint at the end of treatment. So here's the proposed change. It doesn't interfere with the occlusal scheme, the envelope of function in any way, but it does improve the aesthetic desires, satisfies the aesthetic desires of this patient. What I will do here is to make a model of this wax up, and I'm going to use that in a conventional way. With the printed model of the wax up, I will create a PVS matrix that I can use to fabricate provisionals at the time of prepping. So here's the model, the 3D printed the model that's ready for 3D printing. That contains the wax up. We can make a putty matrix of this model, and it'll be very, very nice for fabricating provisionals. So this is a mock-up using the PVS right over the natural teeth. We can get an idea of what our final restoration is going to look like. After putting those provisionals in, and she wore them for a week, she was very happy with the result and ready to prep and design the final restorations in the lab, which is XCAD. Now the strategy is to import and align the approved provisional model, align it to the model of preps, then adapt the contours of the final design to the incisal edge position of the provisional restorations. And if there's a significant change of any kind, we'll insert a trial design using a 3D printed version of the final design. So here we are aligning the pre-op scan, which this is her preps. The tan model is her preps, and the yellow model you see there is her pre-op with her teeth before they were prepped. by telling the computer what some common points are. Now the tan model is aligned to her bite, and we want to keep it the same. So we're going to bring the model of her pre-op model in, and using common points on the posterior teeth, exocad will align those two models. exocad is particularly effective at doing this. We're going to now place the models on the articulator at the approximate hinge position. And with this, we're going to use the measurement from the condylar point to the incisal edge of 105 degrees, which is the average of all arches from the incisal edge to the condylar position. Other than that, we're just going to center it in the articulator. So it's a somewhat arbitrary mount, somewhat similar to a face bow. This technique has been used for years very, very effectively for a wide range of cases. The computer then memorizes the movements, and then we are back into the CAD software to move the case further along. Now I'm going to import a provisional scan. This is a scan of her actual temporaries after we prep the teeth and install the temporaries. So this is the model. The yellow model is the model of her temporaries. The tan model is the model of her preps. And we're just going to use common points again to tell the computer which points line up. And then we'll let it do a best fit matching algorithm beyond that. So there's the final alignment. You can see the lingual of number 7 was quite in lingual version. We over-prepped that in order to try to bring it within the confines of the provisional. But as you'll see in a minute, we didn't quite get it prepped enough. And it will impact our final restoration. For this reason, we will use a trial design printed out of exocad on a 3D printer. The lingual of 7 is not reduced quite enough. That'll become apparent in just a minute. The facial of 7, we didn't have to reduce at all, because the number 7 being in lingual version, the facial of 7 will be completely additive in this process. Right now it looks like number 7 is within the confines of the provisional, but in a minute you'll see it doesn't allow for the minimal thickness of restorative material. I'll show you that in a minute. So now we're just marking the margins of our final restorations. I've sped this up. And then exocad adds the die spacer, the proper amount of spacing, and a lot of the other variables. You can set insertion direction, you can do lots of different things. Most of the time I accept the defaults. I do play with these insertion directions a little bit. Here I am adjusting the one on number 9. So now I'm just going to work with my library teeth and just adjust them so that they fit the shapes of my provisional, because I know my incisal edge of the provisional is in the correct horizontal and vertical position. So we want to position these library teeth so that they're very, very close to that. Now, exocad has a function which will allow you to convert your provisionals to the finals, but that can have some issues as well. Here you see the minimum thickness. The red line is the minimum thickness of the material, and you see how it sticks out beyond the labial incisal of the, or the lingual of the provisional right at the incisal edge. See that in a minute. You can see that red line. And depending upon where you are, in most of the teeth it's in the right position, but on the number 7 you'll see that bump there. That's because of that minimum thickness requirement. So we have two choices. We can either go back and re-prep and re-impress, or we can try to make this, see if we can wax that in and fill that in and create something that is acceptable. Because this is an anterior open bite case, she doesn't go there with her occlusion. My thinking is I can probably blend this out. Now, in the mouth, I can reduce that down some. I can thin that down below the minimum thickness, but I don't like to count on that. I like to see if I can work around it first. So I'm just going to build that up a little bit, thinking that she would probably tolerate this fine. But I would never go to a final case based upon that assumption. I would want to try it in the mouth with this shape and then let the patient tell me if it works for her or if there's any interference whatsoever. You can see we were able to blend that out quite effectively. Now I have increased the thickness of the cingulums. I just think that it was going to give me a little better tooth shape and tooth form. But in the final form, you'll see that the cingulums of these teeth have been increased a little bit. I don't find that's usually too big of a problem, especially in a case like this with an anterior open bite. Now, if there's occlusion down in that area, then obviously you couldn't do something like that. And just kind of waxing in some more anatomy and getting it to a point that I think it's probably good. Now I'll just go around each tooth individually and do some individual shaping of the interproximal areas, the embrasure form, the contact points. Always going back and comparing to the provisionals. In the end, I want to really watch that incisal edge position. Very important to maintain the horizontal and vertical position of the incisal edge because that's been tried in the mouth. Patient likes what she's wearing. The red zone is the minimum of area of minimum thickness for zirconia. That's what caused that bump out on the incisal edge, right at the lingual incisal edge of number 7. And this is the only question I really have with this case, but it's enough to make me want to do a trial design. You'll see that my incisal edge position compared to my temporaries is in the right position. Okay, so these are ready to be individually printed, and they'll be printed as individual single units and cemented as such. There's a comparison to the temporaries. You'll see the cingulums are a little thick, and the lingual of number 7, of course, is a little thick. Everything else blends pretty well, except for its aesthetic enhancements. Here, the crowns are set onto the printer, ready for printing. 4 individual crowns. This is the trial design of those 4 individually printed crowns. You can see how they fit the lip, how they fit the vermilion border. Now we're using Shade Wave to collect our shade photos. These were actually done pre-operatively. Shade Wave uses a cell phone to capture the detail, and then the computer technology will then be able to, being that it knows what the shade of the 2 shade tabs are, it can compare colors within the tooth, within the natural tooth, to bring out the perfect mavericks for the final crowns. When she did the trial, the only comment she has was she noticed the cingulum on number 10. Remember, I made the cingulums a little more full. So before I sent these for final milling, otherwise she was perfectly happy with everything about it. The incisal edge, lingual incisal edge of number 7 did not bother her at all. The cingulum on number 10 did. I decided to flatten all the cingulums just a little bit, because if you'll remember, that was the one thing that I expanded a little bit in the wax up, and sure enough, she caught it. Primarily, she just complained about tooth number 10, but I decided to flatten all of them just a little bit, because that's kind of what she's used to. So now this final design will be sent for milling and returned for cementation. So we'll go ahead and make models and dies. I like to have my crowns finished on dies for emergence profile. I find that mills just cannot mill a flat emergence profile. This really needs to be done the old-fashioned way by a technician, trimming and edging to a die margin. So we always make a set of removable dies as well as a set of base models for them to fit everything back to. The final tryin starts with a single tooth tryin. I like to try a single tooth in, single central incisor, to make sure that the lab in their micro layering has copied my incisal edge with respect to length, horizontal and vertical positioning. You see the very nice shade matching and characterization that the technician was able to pick up from the Shade Wave information given to her. So after cementation, we scanned her crowns back into the original prep, brought these, did an open vertical bite using a leaf gauge, and now I'm making her an occlusal guard for her to wear at night to protect the posterior teeth. So I'm going to set the back of the posterior minimum thickness to be about 2 millimeters. And then I'm going to fill the posterior in to develop a flat plane posterior. You see, so here's a 2 millimeter thick overlay, if you will. Now, right now, the articulator has not been established, so I'm going to fill in this central groove area just so I kind of get a flat plane to work with. Just fill it in and smooth it. Fill it in and smooth it. Bringing up the anterior ramp just to give me some occlusion there. Now we're putting this on the articulator, same process. We're going to go about, in this case, I'm going from the middle of the articulator. It's about 100 degrees from the middle of the articulator to the center of the incisal edge. Setting the parameters of the articulator and going to let it memorize the movements. I also told it to use the bite splint as the determinant of occlusion. If you don't do that, you'll never see the actual occlusion in your bite splint. Now right back here, my splint is a little too thick. It's at 3 millimeters. I'm going to flatten that down so I'm not opening the bite quite so far. I'm going to get that down to approximately 1.8 millimeters. There we have it. I'm going to go back and redo the articulator, because every time you change something, you have to go back and redo the articulator function. So now you can see I'm touching in the back, I'm touching in the anterior, but I'm not touching in the middle, so I'm going to bring these middle zones up until they touch. And notice, I don't even have to have the opposing. I can tell by the little blue marks when I'm getting the right amount of occlusion. And you want the little light shade of blue. The way that I have this set up, the dark blue, even though I know that's what we're used to seeing with articulating paper, the dark blue is actually not touching. There's a slight amount of separation there. The cyan, or the light blue, is where the teeth are just barely coming into occlusion. Now I'm going to cut this. I can tell the computer to ignore the anterior segment. I can cut the posterior teeth to a 0 clearance, where they're just barely touching. And then I can flip those around and I can cut the anterior teeth where there's actually a 0.1 millimeter intrusion. So when it's all said and done, my occlusion will be slightly heavy on the front teeth, and it'll be easy to just reduce that a little bit and get that to pop in properly. You can see how much we've had to add in order to establish anterior guidance. We'll see how this goes. But it is an open bite, so there definitely has to be a significant ramp in the front. And this will be sent off for milling in PMMA. We'll have it back, we'll put it in, and we'll be finished with the case. Alrighty, very good. Thanks for watching. I hope you enjoyed it. Give me your feedback. I'd love to have your comments. Send me an email and let me know how you liked it and what you might like to see in the future. Thank you very much.